Hello and welcome to the Features of Polynomial Rational Functions Part 2 video. This video is going to be a lot like the last one. The only real new piece is that we're now going to be factoring our equations to see if anything cancels out, and the thing that's going to be canceled out is a whole. So before we move on to examples, I just want to talk about wholes for a little bit. So a whole is a factor found in both, oops, that's not how that word is spelled, it starts with an N, numerator and denominator. So it can be found in the top and the bottom of the fraction. The reason being, you cannot have an x-intercept, which is found in the numerator, and a vertical asymptote, which is found in the denominator, at the same time. So an x-intercept is a point, and a vertical asymptote is a line you can't cross, and so they can't interact with each other. So if you find the same factor in both numerator and denominator, that's a whole. So let's take a look at an example of what that might be. So first, let's say you find, you have the equation that f of x, I'm going to pre-factor this for us, is 3 times x minus 2 over, let's see, x plus 3 times x minus 2. So let's say this is our equation. Well, I can see that we have the factor of x minus 2 in both our numerator and denominator. So I'm going to cancel those out, and our new equation is going to look like 3 over x plus 3. But that factor right there, that x minus 2, that's going to be our whole. So our first step we're going to do is we are going to set the factor equal to 0 and solve. So we'll take that x minus 2, set that equal to 0, and we get x is equal to 2. So when x is equal to 2, that's when we're going to have our whole. Now, the whole, or is just an open point. So it's a point, which means we need to find the y value. So the second thing we're going to do is we're going to plug this x into the new equation. Or you can think of it like the simplified equation. So in this case, we're going to find f of 2 with 3 over 2 plus 3. So I'm not plugging it back into the original, I'm plugging it back into the new one. So we have the x value of our whole, we're trying to find the y value, and that's going to be 3 over 5. Last step, since this whole is an open point, we're going to write it as an ordered pair. Right as ordered pair. So in this case, our whole is going to be a 2 and 3/5. So that's the whole. So if you find a factor in both the numerator and the denominator, that is a whole. If you don't, if you factor it and nothing cancels, then you don't have any wholes and you don't have to worry about it. So if you're taking a look at the blank notes right now, we're going to be going over problems 3 and 9. I'll let you know now, they both have wholes, so we'll be able to experience them. This first video just focuses on the features, again, most of which we already know, so we're really just going to be focusing on the wholes for that piece. Next video, we will be talking about the tables as well as graphing with those wholes and what does that look like. But let's start with problem number 3. So I'm going to move this up. Problem number 3 has f of x is equal to 2x squared minus 6x plus 4 over x squared minus x. So what I'm going to do is I'm going to factor out everything I possibly can. Now with an x squared, an x, and a constant, I'm probably going to want to factor, except I notice I can pull a 2 out of all of these in my numerator. So that's going to be 2 times x squared minus 3x plus 2 in my numerator. And then in my denominator, x squared and an x have an x in common, so I'm going to factor that out. So x times x minus 1. Now, when I'm factoring my numerator, I need two numbers that multiply to 2 and add to -3. So this is going to end up being 2 times x minus 1 times x minus 2 over x times x minus 1. So we've gone through, we've factored a problem as much as we can, and I go, hey, I see something in common here. I see an x minus 1 in both my numerator and my denominator, so I'm going to cancel those out. And my new equation I'm going to work with is 2 times x minus 2 over x. So this is the new equation I'm going to be using from everything from now on. But since we factored out that factor of x minus 1, let's look for our whole next. So we factored out. First step we need to do, we need to set the factor equal to 0. So we'll have x minus 1 is equal to 0. So we get x is equal to 1. That's the x value of our whole. Second thing we need to do is to find the y value. So I'm going to take this 1, plug it into the equation. So we get 2 times 1 minus 2 over 1, which is 2 times -1 over 1, or -2 over 1, which is just -2. So we've found the x value and the y value of our whole. And the last step is we want to write this as a point. So my whole, or my open point, is going to be at 1, -2. So these are some of my new features. Now, when we go on to vertical asymptote and horizontal asymptote, we get kind of the same thing that we would do normally. So if I just do my vertical asymptote, I'm going to set my denominator equal to 0 and solve. In this case, my denominator is just x, because everything I do from now on is going to be with a simplified equation. So since that's just x, I'm going to set x equal to 0. I'm going to go, hey, check that out. Vertical asymptote already done. Now, if we take a look at the domain, I'm actually going to have 2 breaks in my domain instead of just 1. I'm going to have my vertical asymptote, and I'm going to have my whole. That's because it's an open point in my graph. I won't actually have an x at 1. That's going to be an open point. So now when I do my domain, we'll go from -infinity to 0, and then 0 to 1, and 1 to infinity. So that first break in the domain is from our vertical asymptote. That's the first discontinuity. And the second one comes from our whole. So you're always going to have breaks in the domain or range if it's an asymptote or if it's a whole. So now, let's look at our next asymptote. Let's look at the horizontal asymptote. Now remember, for our horizontal asymptote, we're going to look at the degree of the numerator and the degree of the denominator. In this case, the degree of my numerator is 1, and the degree of my denominator is 1. So if the degree of my numerator and the degree of my denominator are the same, I'm going to check out the numbers out in front, or the ratio of the leading coefficients, and that's going to be 2 over 1, or just 2. So we can say that the, oops, that's still the highlighter, we can say that the horizontal asymptote is y is equal to 2, and we were able to find that, again, because the degree of the numerator was equal to the degree of the denominator. And if we wanted to write out our range, again, we're going to have 2 breaks, or 2 discontinuities. We'll have from -infinity to -2, and from -2 to 2, and from 2 to infinity, with that first break being the y value of the whole, and the second one being for our horizontal asymptote. So when you're finding the whole, you have to make sure that you use it in your domain and range as well. But from here, we only have 2 more features, x-intercept and y-intercept. So let's try those out. For the x-intercept, you're going to set the numerator equal to 0. And again, we're using our new numerator. So for the x-intercept, we'll have 0 is equal to 2. times x minus 2. First thing I'm going to do is you can either divide both sides by 2 or you can distribute this 2 right here. And you get 0 is equal to 2x minus 4. I'm going to add 4 to both sides. Get 4 is equal to 2x. Divide both sides by 2. And get x is equal to 2. So my x-intercept in this case is going to be 2, 0. For my y-intercept, that's when I plug in 0 into the whole equation. So let's see, this is going to be y is equal to 2 times 0 minus 2 over 0. Now, if I was to go through, I look at this and I go, we're not supposed to divide by 0. That's really bad. So in this case, we have a no solution or no y-intercept. And that's okay, because you may notice that we have a vertical asymptote when x is equal to 0. And when x is equal to 0, that's our y-axis. So if we have a line we cannot cross on our y-axis, we're not going to have a y-intercept. So that may happen sometimes, and that's okay. So this is how we would find all of the features when we are going through and factoring and dealing something with holes. Hopefully not too bad. Let's try one more problem and see what we can do. We'll leave the table and the graph for the next video. Oops, here we go. Let's move this up. So if we take a look at problem, ooh, that's still red. There we go. Problem number 9. Let's see, we'll have f of x is equal to negative x squared plus 9 over x squared plus 2x minus 3. So in this case, when I want to factor, this negative is really throwing me off. So what I'm going to do is I'm going to factor a negative out of my whole numerator. So this becomes negative x squared minus 9 over, let's see, I need two numbers that multiply to negative 3 and add to 2. Those answers are going to be positive 3 and negative 1. So it's going to be over x plus 3 and x minus 1. Now when we go back to our numerator and we factor out x squared minus 9, that's a difference of squares. Or if you want to think of it, two numbers that multiply to negative 9 and add to 0, since we have 0x. So that's going to be a positive 3 and a negative 3. So our equation is negative x plus 3 times x minus 3 over x plus 3 times x minus 1. And taking a look here, I go, hey, we got some things we can cancel out. Some factors here. So when we simplify this, we're going to have negative x minus 3 over x minus 1. And now this is the equation that I'm going to use from now on. Since I was able to factor something out, that means it's a hole. So I need to find where is this hole. First step I'm going to do. So I'm going to take the factor, first step, set that equal to 0. So we'll take that factor of x plus 3, set that equal to 0. We get x is equal to negative 3. This is the x value of the hole. Next, we need to find the y value of the hole by plugging this new x value of negative 3 into the new equation over negative 3 minus 1. So let's see, we're going to have negative 6 over negative 4. Negative times a negative gives us a positive, so we have positive 6 over negative 4. And when we simplify this out, we end up with negative 3 over 2. We reduce our fraction. So our last step, now that we have found our y value of the whole, is to write this as an ordered pair of negative 3 and negative 3/2. You can also write this as negative 1.5 or negative 1.5 if you'd like. But we've found our whole, which is great because now we can use that to write our domain and range along with our vertical and horizontal asymptote. So for the vertical asymptote, we're going to set our denominator equal to 0 and solve. So if we have x minus 1 is equal to 0, we'll add 1 to both sides and get x is equal to 1. So our vertical asymptote is that x is equal to 1. So if we're going to write our domain, we're going to have 2 breaks in our domain. First one's going to be at -3, and that's from the hole. Next one's going to be at 1, and that's from the vertical asymptote. So again, we have a break here from our hole, a break here. Is this still recording? Sorry, I pressed something with my hand. You may have seen a white screen pop up. I apologize. This other hole is from the vertical asymptote. Now from here, we can find our horizontal asymptote by taking a look at the degree of the numerator and the degree of the denominator. So if we take a look over here, I see that the degree of my numerator is 1 and the degree of my denominator is 1. So since the degree of my numerator and the degree of my denominator are the same, I'm going to take a look at the numbers out in front, or the ratio of my leading coefficients. So if we take a look here, what we really have is a -1 over 1, bringing us -1. So our horizontal asymptote is y is equal to -1. And again, we have that because the degree of our numerator, is equal to the degree of our denominator. And when we want to write our range, we're going to have 2 breaks in our range, one from the y value of the hole, one from our horizontal asymptote. So let's see, we'll go from -infinity to -3 over 2, from -3 over 2 to -1, from -1 to infinity, with this first break being for the hole and the second break being for that horizontal asymptote. So this is almost all of our features. The last thing we need to do is find our x and y intercept. So for the x and y intercept, x-intercept, set the numerator equal to 0 and solve. So if 0 is equal to a negative, x minus 3. I'm going to distribute this negative, or -1, in here. So we get 0 is equal to -x plus 3. I'm going to subtract 3 on both sides and get -3 is equal to -x. And divide both sides by -1, or multiply both sides by -1 and get x is equal to 3. So my x-intercept is going to be at 3, 0. And our y-intercept, we're going to find that by plugging 0 in for all of our x values. So this is going to be -0 minus 3 divided by 0 minus 1. Or in this case, -3 over -1. Negative times a negative gives us a positive, so that's going to be 3 over -1, resulting in -3. So my y-intercept is going to be 0, -3. And again, this is all of the features for these problems. If you can get through these problems, these are the most challenging types that we will have. So please check that out. Let me know if you have any questions, and make sure to watch the next video about the tables and graphing. I don't know what just happened.